Okay, so yesterday we were making connections to the assignment that you guys had, the sub-day assignment, right? But it was your electron config. It's going to be renamed, just so you know, in the grade book, because I can't leave it sub-day. It's just weird. So it's going to be like Electron Notation Introduction or something like that. I don't know. It'll be like that. But anyway, everybody did get that turned in for the most part. So if you didn't, I did leave a help video. You just have to click on the link and it shows you the video. I go through the entire assignment. So if you need help still, you got to watch the video. Okay? All right. So yesterday, like I said, we were relating electron notation to what we saw in that POGL assignment, which was the one online. And so at least with electron configuration, we saw that big numbers in the front were originally for the manager's code were the floor. So therefore, they are the energy levels or the periods on our periodic table. The S was your room type, which we interpret now as sub-levels. So those are going to be the different, what you're going to see is they're the different shapes. They're the different shapes of these orbitals. So I kind of showed you that funny little video and the pictures yesterday of like these orbitals, these little bubbles of space of where these orbital or the electrons most likely are, right? So that's what that is supposed to indicate, is the shape. So just so you know, like a couple of the questions today are going to be about the shape, and it's basically S stands for sphere, P stands for is dumbbell shaped, D orbitals are going to be the flower shaped, and then F is the ones that have like flowers with donuts, and we just don't give them a shape. Okay, so we have that, and then we had our number of electrons up here, which originally were the number of people. So my biggest recommendation, because first period already did their practice with this, okay? Keep that analogy in your head, okay? Fill it up with the manager rules, all right? I know that it sounds silly, and it's like, why are we learning about that? It's because that is what's going to keep it simple for now. Get the practice in, understand how to fill these things up, and then we can start looking at some of the stuff beyond that, okay? But you gotta know how to do it first. Right? We got to get that skill first. That's why we have to start from square one. Sometimes it's a silly analogy. It's the best way to learn chemistry, okay? You need to have models in your head that you can actually picture. Okay, so yesterday we started going over orbital notation. So real quick, before we totally continue diving into that, let's give ourselves a little reminder of what we were dealing with orbital notation from the assignment. Right? So we had boxes and we had arrows inside those boxes, right? And stuff like that. So now I understand. I froze the screen. I'm sorry, guys. I was like, why can't you see my hand? I can see it on my screen. All right, there you go. All right, so you had boxes. So I would draw this little picture right here. We're just going to add a couple labels. So those arrows, we went over it yesterday, but just in case, the arrows from the analogy were the people, right? And so we changed those into electrons, okay? Remember, your electrons are matching up to your atomic number. The total number of arrows in your entire picture should be the number of electrons that are in that atom, which is the atomic number, okay? Then we had these individual boxes. So an individual box from the analogy was the bunk bed, which means that you have to fill it up according to the rule that the manager set, which was fill up all the bottom bunks first, then you fill up the top bunks. That is how those electrons fit into these orbitals. They can't double up first. These things are constantly repelling each other. So in order for an atom to exist at the lowest energy level possible, not these energy levels, but just the way the universe works, it's a bunch of physics topics, okay? So when you get later on in your science careers, okay, you'll start learning about that kind of stuff, all right? Electron configuration is actually dealing with like angular momentum and gosh, I forget all the words, but there's all these little things. Electron configuration is actually more than what we learn right here. So just be aware of that, okay? There's a lot more to it. Every electron has an address. All right, so we kind of skimmed the surface in chemistry one, so keep going with it. So bunk beds, those things are called orbitals. Those are what hold the electrons. the little bubbles of space where they most likely are. And then a group of those, such as when we're dealing with the P sublevel, those are known as sublevels, but that would equate to, I ran out of room, so I'm not going to write it, but that would equate to having the pink room, right? I'll zoom in because I know you guys can't probably see those words, okay? But that is what we're dealing with here.
So is it the room type, right?
No, sublevel is the room, yes, room type, sorry, yes, you're correct. Yep, so pink rooms versus sunny rooms. We haven't even learned about the D sublevel yet. Okay, that one held 10 people. There's 5 bunk beds in there. Okay, all right. So just kind of keep the simple analogy in your head as you guys are progressing through the practice problems today. Okay, all right. So this is where we kind of left off. We were writing in our orbital notation. So something that I'll kind of also point out is you can definitely, we provide lines. Sometimes we put X, Y, Z. But really, what this is actually, I don't know. When I first learned this stuff, it was easier for me to think of it as a whole box. A box with 3 spaces, right? And that way I knew that those guys were linked up together because they were all on the same distance away from that nucleus. They're sat at that specific area around the nucleus. That is how they come together. There's a bunch of forces going on inside of an atom. We've got repulsion and attraction going on at the same exact time. That is how they fit. So, carbon, okay? We started writing down the electron configuration underneath. So we said 1s2, 2s2, 2p2. What were we talking about? What was 2p2? What did that mean? Second row. Where's the P sublevel? On the right hand side, right? So 13 through 18. And then what did the little 2 stand for? How many electrons, right? So we count over 1, 2, and that's carbon. Okay? So one thing that helped first period is taking their finger, follow your periodic table like a map. That's what's going to get you through it. Follow it like a map. That's what it's there for. Okay? And that is all we're doing for electron configuration. But back to orbital. So when you go to fill these up with the arrows, we got to follow that manager's rules, right? So first floor, sunny room. We fill up that bunk bed right away. Then we're like, okay, now we can move to the second floor. So second floor, sunny room, fill up the bunk bed. We're now at 4. We have 2 extra people. So we can't go to the third floor. We have to fill up the pink room next. We only have 2 people. Can we put them both into the same bunk bed? Think about the manager rule. No, you give them each their own space until you have to double up the bunk beds. So we're going to go 1 and 1, just like that. Up, up. Okay? And that would be the orbital notation for carbon. Okay. So, down here for electron configuration notation, right? So this is just dealing with the manager code. So this is one where we had letters and numbers and we put them together. All right, so when we are doing electron configuration, that's going to eliminate your orbitals or the boxes, right? So the boxes are the lines. And eliminates the arrows, which was showing you the spin. Was it going forward or was it going backwards? They cannot spin the same way. And that has to do with the repulsion. And you have to fill up separate orbitals because of that repulsion. Okay? All right. They want to exist at the lowest energy possible for staying there. Remember, if they're constantly dealing with repelling each other, they would have to use energy to try to push themselves closer together. So they're not going to do that unless they're forced to. Okay? Just remember that. That is why we have the organization that we have. All right. So instead, we're going to use an exponent. Sorry, I should say N. To indicate the number of electrons per sublevel. Okay? Per sublevel. It is important to remember your maximum number of electrons per sublevel. This is how many people you were limited to for each room. So you guys can start me off S. How many people were in the S room? Sunny room. Maximum. There was only two. Sorry, I held up one. One bunk bed, 2 people. All right, so 2 people. Good. How many people were in the pink room? Maximum. It goes up to 6. Good. So now I'm going to show you where you can find this answer on your periodic table. Okay, so we kind of talked about it yesterday. So we already know, and I'm going to get you guys little periodic tables. When you guys start working on your stuff, I'm going to get you little periodic tables that you'll be able to kind of color in and label, or you can do it on your own periodic table. But this right here is our S sublevel, right? The first 2 groups on the periodic table. Over here is our P sublevel, so 13 through 18, not including helium. Remember, we include helium over here. Okay. So the one that you don't know yet is right here. So D is going to be all your transition metals. F is going to be these bottom 2 rows that sit kind of within the periodic table, but we put them down here. Now, I said I was going to tell you how to find this answer, right? So S had 1, 2 maximum, right? P had 6 maximum. 1, 2, 3, 4, 5, 6. So D, how many maximum does that one have? If you have your periodic table, does anybody have it over here? You can count it up here. That's 10. Yeah, we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So D can have 10. So we're going to put 10 right here. That's their maximum. And then F, I won't torture you. That one's going to go 2, 4, 6, 8, 10, 12, 14. It goes 14 across. Okay? So 2, 6, 10, 14. So put a little squiggly line, because that's all fun and games, but you got to know how many lines to draw when you're dealing with orbital diagrams. So we should also know how many orbitals each one has. So remember, orbitals were the bunk beds. So start us off. Let's just label orbitals real quick. Okay. How many bunk beds were in the sunny room? How many? 1. There's only 1. How many were in the pink room? 3. So you can kind of see the trend here. We cut it in half. So how many are going to be in the D sublevel? 5. How many are going to be in the F sublevel? 7. Exactly. Okay? So again, these are the orbitals. These are those little bubbles of space. Okay? This kind of also tells you, so kind of yesterday when I showed you the shapes, like the little dumbbell shape, how it was one going this way, one going this way, one going up and down, right? That was the 3 orbitals. So that means this one is going to have 5 of those fitting together. This one's going to have 7 of those. So you can kind of see why the pictures got a little bit more complicated as we were looking towards the bottom of that picture yesterday, right? So this picture that I was kind of showing, that's why this one has 7 axes, basically. Crazy, right? A little crazy? Yeah, I think so. All right. So, yeah. Awesome. All right. And actually, while we're here, because first period we didn't do this with them, so I'm going to go ahead and say, I want you to put one more squiggly. We're going to put the shape. Okay? All right. So the shape of your S sublevel, what does it look like? This is cut in half, by the way. What would it be if it was finished? What shape is that? A sphere, exactly. Yep. Okay. This one looks like a dumbbell. So dumbbell is for P. D, we go ahead and say it's technically a double dumbbell, but it's okay for you to say flower. Oop. Because if you remember yesterday, I had put on your page there we go. So it's dumbbell, double dumbbell, and then we put very complex. All right. So the double dumbbell, if you kind of look at it, a lot of them look like they could be flowers, but the very complex looks more like flowers. So we're going to say double dumbbell for that one, and we're just going to put very complex for complex. We don't even try to define their shape. They are 7 axes. Imagine that. All right, cool. Okay, so now let's get a couple practice things in so that you know how to do the manager's code. So remember, that is what you're thinking right now, manager's code. So if you have a periodic table, I would have that on your desk so that you can try to imitate what I'm doing. I'm going to show you the thought process here, okay? So I would have that on your desk. Otherwise, if you want to borrow, I have a couple periodic tables up here by the tissue box over there, okay? All right. So our first one is hydrogen. So that one's pretty easy, but we're still gonna go through that process, okay? So I'm gonna move helium right here just so I'm thinking that. All right. So hydrogen, we are going to, you have to start from hydrogen every single time, by the way. All right. So here we would say, okay, I need to have my energy. We need to have an energy level, a sublevel, and number of electrons. Energy, sublevel, number of electrons. All right. So knowing that, we have to define this. So what energy level is hydrogen in? 1. So we're going to put a 1. What sublevel is hydrogen in? What? S. Good. How many electrons does it have? 1. So that one's pretty easy. Okay. Helium. Say it again. So we have first energy level, S sublevel, and it's 1, 2 over. So we're going to put a 2. Okay, so for lithium, here I'm going to write in a different color. That way it doesn't get all mixed up. Lithium is next row up, right? You still have to start with hydrogen. So we're going to say, remember, this is a manager's code. You've got to say how many people are in there. So with an electron configuration, you're telling us how many electrons are inside that atom. That's why we're doing this. All right. So for lithium, we start at hydrogen. So we have 1s1, 1s2. So we have to fill up our sunny room first. So 1s2. Then we can move to the second row. So that'll be 2, still s, and how many over? Only go 1 over. So question last period was, well, why don't we put 3? Because we have a maximum of 2. It's talking about how much are you filling up that little bubble of space, right? So we say 1s2, 2s1. That's where we're at, okay? All right, beryllium. So we're next one over. So we're going to go 1s2. We fill up the first row. 2s2. All right. So now we're going to be jumping across. So boron is over here. So what are we going to end on at least? A P, but 2p1, exactly, all right? So it might help, and I kind of told last period this is what I used to do. I used to put the last one and then work backwards so that I could just know, okay, that's where I need to stop, right? Otherwise you just keep going because you're like, oh, 4s, 2, and 7, whatever, and you forget where you're at. So for boron, we would start at the beginning. We would have 1s2, 2s2, 2p1, and that would be where you stop. So oxygen, you guys tell me that one. What's the first thing? 1s2, 2s2. So we're at beryllium right now. What's next? So 2p4. Good. Yep. So 1, 2, 3, 4. And that's how far you're telling them. And just so you know, you can always add up your exponents and make sure when they add up, that's your atomic number, right? You're trying to get to 8 at the end. So 4 plus 2 plus 2 is 8. So that's where you ended. Okay? All right. So groups 1 and 2 tend to be called the S block elements because their valence electrons is in the S sublevel. Groups 13 through 18 tend to be called P because their valence electron is in the P, and I don't like that we call it an orbital, sublevel. What is the exception to that? Who's the exception to p orbital or p sublevel? Huh? Helium, exactly. That one ends in the s sublevel. Good. All right, so for neon, we had 1s2, 2s2, 2p6. So when we're looking at the orbital diagram of this, I'm just going to go ahead and make this my 3 lines for the 2p sublevel. I don't mind if you cross this out and just start putting 2p for the group of 3. We probably won't ever ask you x, y, z, okay? It's assumed. All right. So when we're filling this up, we have 1s2, so we're going to go up, down. We're filling it up just like the manager does his house, right? So sunny room filled. Second sunny room, fill up. And then we're going to fill up the pink room. Now, watch this because it's really important. Do we just start doubling up the bunk beds? No, you go up, 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 down, 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 and get yourself into that habit. Is it going to get filled up? Yes, but get yourself into the habit now for the ones that aren't going to get filled up, right? Cool. All right, and just in case I don't get your guys' copies of the periodic table done ahead of time, just draw yourself really quick, just a little periodic table down here. And include that little extra row. And all you're going to do is just write S, P, D in the middle, and then F over here, okay? And that way, you just have that to refer to when you look at your own periodic table. Okay, so I'm going to hand you out a practice page. You should be able to finish it, front and back. I have the key available so you can come check your answers when you're done. It does not go into the D or F orbitals, sublevels, so we don't have to worry about doing that. Because on the back of your notes page, do not lose your notes, by the way. Okay, we got to continue these tomorrow. I'll go into how D and F work. Because it is not, as you can see what happened right here. 4s, 3d, 4p. Weird, right? So on the 4th energy level, we actually fall back in energy level when you get here. Okay, so I'll go into detail on that tomorrow. So don't worry about it today. Don't worry about the back of your notes page today. We will do that tomorrow. But the one that I'm going to hand you right now looks like this. So you'll start with electron configuration. You should be able to answer all of these on the front. The bottom one, you're picking which ones are the correct ones. And so make sure you're able to tell me what's wrong with the other ones. You don't need to tell me the rule name, just what's wrong with them. And then on the back, you have orbital diagrams. Please note, you have to put these labels underneath your boxes and your lines. Don't forget to do that, okay? All right, so I'm going to hand this out. That way you guys can